So first of all, OSPF stands for what?
Open short path first.
And whenever interviewer will ask you directly, they explain any dynamic routing protocol, like interviewer is asking you to explain EIGRP. How you will explain EIGRP?
It's a hybrid protocol.
First of all, EIGRP stands for what? Okay, so first of all, yes, we will mention full form. Then we will mention what AD value that protocols is using. Okay, like EIGRP stands for Enhanced Interior Gateway Routing Protocol, which uses AD value 90 and 170, 90 for internal, 170 for external. It is using multicast address 224.0.0.10, and this routing protocol is used to share the network information with their neighbor. So if you will answer like this, definitely interviewer will impress with your answer. Okay.
Right, sir.
So OSPF stands for Open
Short path first.
Open Shortest Path First. Okay. This is a Layer 3 protocol. OSPF is an Layer 3 protocol. It is an Layer 3 protocol. That means all traffic of this protocol will be encapsulated at which layer? At layer 3. Fine. Second thing here you need to mention is OSPF is an open standard protocol. That means we can run OSPF on Cisco devices as well and on non-Cisco devices as well. Okay. Open. EIGRP was earlier EIGRP was Cisco proprietary, but later Cisco declared EIGRP as an open standard, right? But OSPF is an open standard routing protocol at the time of initial, right? At the time of launching this protocol. So it is an open standard protocol. Yes.
Which team defined that all protocol, that EIGRP?
Same organization, INA. Yes. So suppose if I am designing a protocol, I need one multicasting address, right? So I have to purchase multicast address from the organization called INA, and I have to tell them everything that I am going to design this protocol. I want to use a multicast address. AD value for this protocol will be this one. My protocol will work like this. So blah blah blah. Okay. And if your design, your method is absolutely okay, fine, then definitely organization will pass your protocol. They will check everything, and if really it is beneficial, it will be beneficial, then it will declare open standard as well. Okay, so companies can use that protocol in their devices. Fine. Now it is an IGP protocol. So what is the meaning of IGP?
Interior Gateway Protocol.
Interior Gateway Routing Protocol. That means this protocol will also work within AS.
Yes.
Right? After that, it is an link state routing protocol. What is the meaning of link state?
Depending on the state of the link, that is neighbor up or down.
Yes, there will be 3 types of table, right? A router will have complete information of topology. Okay, first of all, OSPF will form neighborship, then adjacency, then they will share routing information. Like EIGRP, OSPF is not going to share routing information directly. In OSPF, router will share database. Okay, router will share actually the information of link with their neighbor. That suppose a router have 5 active link. So router will share the information of that 5 active link with their neighbor, and their neighbor will decide that which path will be best for all the prefixes, right? So these things we are going to learn later. First of all, let me tell you some basic things about this protocol. So it is a link state routing protocol. That means it will maintain 3 types of table. neighbor table, routing table, and topology table. Okay, then it uses protocol number is what? It uses protocol number 89. Okay, that means the traffic of OSPF will be encapsulated with IP protocol, and in IP header protocol number will be always 89 for OSPF traffic. What is the protocol number of EIGRP? Hello? Oh my God, what happened?
Yeah, we can hear you.
I am asking you, what is the protocol number of EIGRP?
I think 88.
Yes.
88.
So why you guys are taking so much time?
I am confused about that DHCP server 66 or 67.
Those are port number, not protocol number. There is a huge difference between port number and protocol number. Protocol number will be added in IP header and port number will be added in TCP or UDP header.
I can little bit confused, so I will take time. It will take time.
No. Always keep in mind protocol number of EIGRP is 88 and protocol number of OSPF is 89. Okay, after that it uses what? Multicast address. So it uses multicast address, that is 224.0.0.5 and 224.0.0.6. Now very interesting question is here, why OSPF is using two multicast address. Okay, so definitely we will discuss later it why OSPF is using two multicast address. Okay, that means is using
only one.
yes
0.0.10.
10, right. RIP is using .9 only in RIP version 2, and in RIP version 1 uses broadcast address 255.255.255.255. After that RIP version 2 using .10 or 9. Yes, 9. Okay, EIGRP 10 and OSPF is using these two multicast address. Fine. After that, like EIGRP uses dual algorithm to calculate best path, OSPF will use SPF algorithm. SPF stands for shortest path first. It is an algorithm. Full form of OSPF is open shortest path first. Open shortest path is an algorithm, and open is indicating that it is an open standard. So that's why we say OSPF stands for open shortest path first. Open shortest path first means shortest path is an algorithm and open means it is an open standard. So it uses SPF algorithm to calculate best path.
It's based on the Dijkstra algorithm, right? So it is also used in project management for.
Yes, exactly, sir. Okay, fine. Then here, how router will calculate metric? So like in RIP, metric is hop count. In EIGRP uses formula to calculate metric, that is 10 to the power 7 upon list bandwidth plus total delay upon 10 whole multiplied by 256. But here in OSPF, metric will be the cost, and formula to calculate cost is reference bandwidth upon bandwidth of link. Okay, so we will understand how OSPF will calculate cost, right? So this will be the metric, reference bandwidth upon bandwidth of link. So reference bandwidth will be the predefined value, and this is changeable. We can change it, reference bandwidth, and we will discuss when we need to change reference bandwidth as well. By default, reference bandwidth which is configured on all Cisco router is 100. Okay, so this is reference bandwidth. Okay, now next point you can mention over here is cost for serial link. So if you will calculate cost on serial link, So you know what is the bandwidth of serial link? So tell me what will be the cost on serial link if you know the bandwidth of serial link, because reference bandwidth is by default 100. So tell me what will be the cost on serial link. Tell me what will be the cost on fast Ethernet link or on Ethernet link.
Cost on serial link will be based on 1.54 Mbps.
So what will be the total cost? 100 upon.
1.54.
So what value you will get? I think you will get 64. And on Ethernet link, 100 upon
100 upon 100.
100 upon 100 or 10 upon 100 or 100 upon 10. 100 upon 10 it will be 10. And cost on fast Ethernet link will be 100 upon 100, right? So it will be 1.
प्रफुल सर ये समझ नहीं आया थोड़ा मुझे कॉस्ट ऑफ सीरियल लिंक कितने डी
डोंट वरी, आ जाएगा ये सब चीज़ें समझ में आपको भी। देखिए मैं क्या बोल रहा हूँ कि बैंडविथ आपको पता है सीरियल लिंक की कितनी होती है प्रथा सर?
1.544.
Yes, let's say 1.5, right? So if we want to calculate cost on serial link where bandwidth is this one, right? So formula to calculate cost is reference bandwidth, and I am saying that by default reference bandwidth is configured as 100. So 100 upon 1.54 something, right? So you will get 64 here. As you know, bandwidth of Ethernet link is 10 Mbps. So how you will calculate cost on Ethernet link? Reference bandwidth is again 100 upon my bandwidth of link is 10, so it will be 10. As you know, bandwidth of fast Ethernet link is 100 Mbps. So reference bandwidth is also 100 and bandwidth of my link is also 100, so it will be 1. Okay. So this is how I am calculating cost. Fine. Okay. So here I am mentioning as well by default reference bandwidth equals 100 Mbps. Okay. So these things you also need to mention in your notebook, right, for further use. After that, I am going to discuss how many types of messages are there in OSPF. So next topic is suppose types of messages. Okay, so number 1 is again hello message, and same use of hello message here, right? Discover, never, and keep alive. Okay. Second type of message is, first of all, can anyone tell me the name of messages in EIGRP? How many types of messages are there? 5. Can you tell me the name of all 5 types of messages?
Hello query.
Hello, directly query or hello then update?
hello update query.
Query.
Hello update query.
Okay.
Acknowledgement.
Last one. Reply acknowledgement.
Reply acknowledge.
Okay.
Hello.
So at your free time, you know, when you are working or when you are not doing something, that time just try to memorize these things. Just try to ask the same question. Like I am asking to myself, Praphul, do you know how many types of message in EIGRP? Okay, yes, I know. Hello, update, query, reply, and acknowledgement. Hello, update, query, reply, acknowledgement, like this, right? Then only everything will be fit in your mind, right? So you don't need to invest your force to answer in front of interviewer. Okay.
Right.
So try to memorize these things, right? Message, multicast address, AD value, protocol number of each protocol. Okay, so here second type of message is DBD. DBD stands for database description. Database description. Okay, third type of message in OSPF is LSR. LSR stand for link state request. Link state request. Okay, fourth type of message in OSPF is LSU. LSU stand for link state update. And fifth type of message in OSPF is acknowledgement. Right? So OSPF have their own acknowledgement message, right? So OSPF will not use any protocol for reliability. Okay, now guys, what is the use of hello message? Hello message is used to discover neighbor and keep alive. Okay, to discover neighbor and keep alive. And always keep in mind, hello message will be sent on multicast address 224.0.0.5, right? But in some case, hello message will be sent on unicast address, when unicast in case of static neighborship. So as you know, we can configure both dynamic neighborship as well as static neighborship. So it will send multicast hello message every time except when you will configure a static neighborship. So it will send unicast in case of a static neighborship. Okay, fine. So these are 5 types of message. Now we are going to discuss content of hello message first. Okay, so I am going to show you as well in GNS3 what will be the content inside hello message. So our next topic will be content of hello message. Okay, so hope this is clear. Now content in hello message. Okay, from here we are going to mention so just I am taking 2 router. Let me power on the device and let me connect these 2 devices together. So topology is visible. I am going to capture this link and let me configure OSPF. Hope topology is visible to everyone. Now interface F0/0 say no cert and IP address is 12.1.1.255.255.255.0. Let's say, let me do same thing on router 2 as well. Configure T, interface F0/0 say no cert and IP address is 12.1.1.2.255.255.255.0. Do ping 12.1.1.1. So yes, I am able to ping. Now I am going to configure OSPF. First let me configure on router 1. So router, OSPF, then process ID. Here we need to define process ID, not AS number. Then network 0.0.0. Wildcard mask is 255.255.255.255 and say area is 0. Okay, don't worry about the configuration. Router OSPF process ID 1 and suppose network 0.0.0 and wildcard mask 255.255.255.255 area is suppose 0. Now let me check the hello message. Where is hello message? Here it is. So just I am opening it. Okay, so here you can see in hello message there are 3 sections, right? So I am opening first of all header, OSPF header, right? In each packet there will be a header. In header you can see there is information of version, then types of message, that which type of message it is. As you know, there are 5 types of message in OSPF. Out of that 5 message, this is an hello message. Okay, so there is information of version, types of message, then packet length. After that, source router, source OSPF router, and then area ID, then checksum, authentication type, and authentication data. Fine. After that, you can see subnet mask, hello interval, priority, dead interval, designated daughter ID, and backup designated daughter ID. There is information of again checksum and some external information is here. Okay, so leave these things. So now I am going to mention here what information I have checked. Okay, so there is information of version, right? So version is 2. After that, types of packet message. So here you can see value is 1, and then there is information of length. Okay, then there is information of router ID, then there is information of checksum. Then let me check again. Okay, then there is information about authentication type. After that, authentication data. Then there is information of subnet mask. There is information about date time and hello time. Dead interval and hello interval. Okay, and there are some more information like priority. There is one more information about DR router ID, DR router ID. There is information about backup designated router ID, so BDR router ID. Okay, after that there will be information about we can say neighbor router ID as well. There will be information about neighbor router ID. Okay, so these information hello message will carry. Okay, this information will be carried by a hello message. Okay, out of these messages, some parameter must match to form neighborship. Let me discuss about that parameter first. Okay, first of all, tell me in EIGRP to form neighborship, is hello interval and date interval should match? My question is, to form neighborship in EIGRP, is hello and date interval should match? No, right? That is locally significant. But here in OSPF, date interval and hello interval must match. Okay, because here now you can see, so IP OSPF neighbor. Who is neighbor? 12.1.1.2. But if you will change the hello time, interface F0/0 IP hello interval for OSPF for EIGRP. Note for EIGRP. Here I think command is different to change hello time. Router OSPF 1, then IP hello. Okay, let me check the command. Okay, just I will do it later. Just give me some time. What I am saying, in OSPF, hello and dead interval must match to form neighborship. So I am going to discuss what parameter is required to match. Okay. So first thing that should match to form neighborship is
Dead interval and hello interval.
First requirement is router ID must be unique. Okay. Because as you know, router ID is identity of router. So two router cannot use same router ID. Okay.
Okay.
To form neighborship, first requirement is router ID should be unique. So parameter for
I show your question on this, that OSPF, and you said that answer is MTU size must be matched.
yes. So those things we are going to discuss here. Okay. So first thing is a router ID, and in interview people are saying that router ID should be matched to form neighborship. So always keep in mind router ID must be unique, not match. Okay. Second thing is hello
Interval and dead interval.
and dead interval must
Be same.
time must match. Okay. Third thing is subnet mask must match. Must match. Fourth thing is MTU must match. But where is MTU? Is hello message carrying MTU information? Okay, so don't worry, just listen now what I am saying. MTU must match to form neighborship. That means there will be information of MTU as well. Okay, later I will show you. MTU must match. Then fifth thing is authentication type and authentication data.
I think there should be
Location.
area ID must be same.
Yes, data must match. Sixth thing is area ID. Area ID must match. Seventh thing is stub flag must match, but now I am not going to discuss about stub flag. Network type must match. Okay, network type must match. Okay, so these are requirements to form neighborship in OSPF. Okay, is it clear?
So in this only router ID must be unique, otherwise
All the information should match. Yes, fine. Now we are going to discuss what is router ID. So what is router ID? Who will explain?
router ID means
What is a router ID?
A unique identifier to a router.
Okay, it is an unique, it is an 32 bits unique unique identification of a router. So actually router is using router ID to represent their database, right, in the OSPF domain. Okay, how router will represent their own database and how router will differentiate the neighbor database or database of any router in OSPF domain with the help of router ID. Okay, and it is an 32 bits address which is represented in IPv4 format. Okay, so represented in IPv4 format. Okay, after that, anything else about router ID? We have two options to configure router ID on a router: manually and dynamically. Okay, so command to configure router ID on a router manually is router OSPF process ID. Okay, and then simply you will run a router ID, suppose 1.1.1.1. Okay, let me show you. If I want to configure router ID on router 1, so first thing you need to go in OSPF mode, and here you will define router ID 1.1.1.1. So what it's saying, OSPF reload or use clear IP OSPF process command for this to take effect, because this router have already shared their database. This router is using different router ID, and this router is already shared their database with their neighbor, and now you are changing router identification. So is it possible? No, then my neighbor will get confused, right? So if you want to change, first you need to break neighborship with my neighbor. So what I am going to do, I am going to clear IP OSPF process, say yes, and now I am going to define router ID. So router OSPF process ID 1 and then router ID 1.1.1.1. Now you can see how to verify. So IP protocol. So IP protocol, here you can see router ID is now 1.1.1.1. Okay, so this is very simple how manually we will configure router ID, but how router will elect dynamically, this one is very important, right, for interview as well, because there are lots of questions interviewer can ask to you. So yes,
We change the router ID at router 1.
okay,
So no need to change na, that router 2. It automatically.
no, router 2 is using different router ID. Let me check. So I
Got it.
okay,
First time we not apply router ID to router 1 and router 2.
so routers use dynamically method to configure router ID.
Okay. So okay, my concern is like if we change the router ID at router 1. So
Okay.
no need to change another router ID to router 2. It automatically taken by router.
No, why router 2 will change their router ID? Router 2 is still using previous router ID. I have changed on router 1 only. Okay, no need to change on router 2. Router ID must be unique. What will happen if I will set same router ID over here? So this can be your question. First of all, I need to clear IP OSPF process, then only it will allow me to change router ID. So let me configure same router ID or router OSPF 1 and say router ID is again 1.1.1.1. So my god, do clear IP OSPF process, say yes, and router ID is 1.1.1. Now I have configured same router ID on both router, on router 1 also and on router 2 also. So IP OSPF neighbor. So neighborship is not showing, right? Because to form neighborship, router ID must be same. So when router 2 will receive hello message from router 1, it will check router ID and router ID is same. It will not form neighborship.
Okay, so even network also not provide error. It take the same router ID.
Yes, it will take, but neighborship will not form.
Oh, that understand.
And
I think we.
if you will debug, if you want to check that why neighborship is not forming, then you will debug OSPF packet, yes or no. IP OSPF packet, and which packet? Hello packet. Let's say all packet. Okay, so when it will send hello message and it will receive hello message, you will see in both message router ID will be same. See, router ID is 1.1.1 from 12.1.1.1. Yes.
There is a mention OSP detected duplicate router ID.
Okay, so now I am disabling debugging and all. Fine. Now concern is how router will elect router ID dynamically. So first of all, router will check what? Router will check. If you will not define manually router ID in OSPF, what router will do? Router will look up for the loopback interface. If loopback interface is available on router, right, then it will use that loopback IP address as a router ID. What I am saying? First step is it will look up to loopback interface, right? And suppose if there is more than one loopback exists, then loopback where highest IP address is running, that will become router ID. So you can say first method is highest loopback interface IP will become router ID. And if loopback is not exist on a router, then router will do what? Then router will check highest IP address on physical interface of router. Highest IP address on physical interface. Okay. If physical interface is also not available, suppose there is no any active interface on a router where you are configuring OSPF, then router will elect router ID as 0.0.0.0. Okay. So definitely from OSPF interview will ask you question from this topic, right? How router will elect router ID in OSPF. Okay, so configuring manually is very simple. Okay, and when engineer will not define router ID manually on a router, then what router will do? Router will first check. See, on router number 1, I am going to disable OSPF. Say no router OSPF process 1. Okay, and I am going to set the interface F0/0 interface. And here I am going to configure OSPF. Say router OSPF process ID is 1. Now once you will run this command, first of all router need router ID. Okay, and it's saying here you can see log message OSPF process ID 1 failed to allocate unique router ID. Okay, because we don't have any loopback interface exist on this router, we don't have any physical interface on this router, so router is not able to find a unique ID for router ID, and router will actually, router will run the process, but it will elect router ID as 0.0.0. You can see over here. Fine. Now I am going to disable OSPF again from this router. Say no router OSPF 1, and here I am going to create some loopback 1 IP address is suppose 1.1.1.1 255.0.0.0. I'm going to create one more loopback 2, and here IP address is suppose 10.10.10.10.10. Fine. 255.0.0.0. Okay. There are some physical interface F0/0 say no set, where I am running IP, which IP 12.1.1.1. Okay. So this time if I will configure OSPF here, what router ID will be elected as router?
Highest IP
on loopback interface. So IP router OSPF 1. So IP protocol. So see router ID is
10.10.
What will happen if I will down the loopback interface 0 or 2, say shut down.
We will take from loopback 1.
Why? Once router will elect router ID, it will not going to change it. Right? This is not the IP address of loopback interface. This is identification of OSPF router. So just the OSPF router need one ID. Okay.
Okay. So if we shut the loopback 2, then even the router ID will be same.
Yes, exactly. And if we will clear the OSPF process, so again router need to elect one router ID. So this time this loopback interface is not exist, right? So this time router will select IP address on loopback 0 interface, which is yes, clear IP OSPF process and say yes. And now if you will check so IP protocol, here you can see, oh my god, it says still router ID is 10.dat, so IP interface exclude unassign. So you know why it's taking 10.10.10, because this IP address is already still available. Still this interface is down, no problem, but IP address is available, right? So I am going to remove this IP address from loopback 1 interface, loopback 2 interface. So interface loopback 2 and say no IP address. And now so IP interface brief exclude assign. Here you can see this loopback is not exist now. Now I am going to clear IP OSPF process. Say yes. So IP protocol. Now you can see router ID is 1.1.1. And suppose there is no loopback exist on router, say no loopback 1 and no loopback 2. Sorry. No interface loopback 1, no interface loopback 2. Right? Now so IP interface brief exclude and assign. Okay, here you can see only physical interfaces exist on this router. And now if I will clear IP OSPF process, again OSPF is going to elect router ID, and this time
it will take from the interface.
yes, so IP protocol.
Yes.
Okay, so we have discussed how to configure manually router ID on a router and how router will elect dynamically if engineer will not define manually. Fine. So router ID must be unique. Okay.
So,
Yes. Any question to anybody?
if there are two routers which are neighbors,
Okay.
both have full loopback,
Okay.
then how will router have unique ID?
You are saying that we have two router, both are directly connected. On both router we are running two loopback, right? Suppose 1.1.1.1 and 2.2.2.2.
Yeah, one loopback, which is say
Okay, 1.1.1. Okay, and here also I am running one loopback with same IP address, right? Okay, this one is my router 1 and this one is my router 2. Both will elect 1.1.1 as their router ID, yes or no? So neighborship will not form between router 1 and router 2. Then you need to change router ID manually. Okay. So let me do same thing.
it's difficult because
Yes.
if it is yeah, so if it is electing based on the IP address of the interface,
Okay.
then there might be same interface.
Yes. I am saying no router OSPF 1. On router number 2 also, let me run no router OSPF 1, and here I am going to create one loopback where I am going to run same IP 1.1.1.1 255.255.255.255. Okay, so on both router I am running one loopback where I am running same IP address. So IP interface brief exclude unassign. Fine, Pratha sir? Right, this is your question. So IP interface brief exclude unassign. Fine. Now I am going to configure OSPF on both router. Okay, sir?
Yes.
Router OSPF 1 and network 0.0.0 and 255.255.255 area 0. Here also and here also. Router OSPF 1 and network 0.0.0 255.255.255.255 area 0. See the log message.
Duplicate.
Okay, sir.
Yeah.
Anything else?
So, I mean, we'll have to take care of not having. I mean, there might be
Yes,
two routers in the network which may have same.
exactly. That's why I have mentioned it on top that router ID must be unique to form neighborship. You have to take care of it.
Configure manually.
Yes. Yes, in real time, it's recommendation to configure router ID manually on router, right? Like if you are configuring OSPF on router 1, you should configure router ID 1.1.1. On router 2, you should configure 2.2.2, right? It will be very useful, very helpful while troubleshooting. If you will configure router ID with the number of router.
Okay, Professor.
Yes.
So if OS if router router ID by default from its router interface.
Okay.
So it by default is unique na every time because every interface have a unique.
What will happen if someone will configure same IP address on both router interface? Then also router ID can be same. So whenever actually you will get log message that router ID is the duplicate log router ID. So you should have knowledge that router ID must be unique, and here I need to change the router ID on a router, right? So this is the trouble. This is our troubleshooting step. Okay. So why I'm spending much time here to so that you can identify these log message. Okay. That's it. Fine. So to elect router ID, first of all, router will look up on the loopback interface. If loopback is exist, that IP address which is running on loopback will be elected as router ID. If more than one loopback is exist on a router, then highest IP address of loopback interfaces will be become router ID of router. If loopback is not exist on router, then highest IP address of physical interface will be elected as router ID. If physical interface is also not available on the router, then router will elect 0.0.0 as a router ID. Okay. Clear?
So if both router there is no interface and no loopback, so
Okay.
both should directly take 0.0.0.
Suppose there is no physical interface as well. You have not configured IP on physical interface on both router. Yes. So both will take 0.0.0. But you know, when router will take 0.0.0, it will give you one log message as well that router is unable to elect router ID. Okay. With router ID 0.0.0, router cannot form neighborship. It will only enable OSPF, but OSPF will not work on router. Okay. Fine. Now very important thing is OSPF neighborship state. To form neighborship between two router, first thing we have discussed is router ID. Router ID must be unique. Now we are going to discuss how two router will form neighborship with each other. For that, as you know, this router will send hello message. Right, in the same way this router will send also hello message. First of all, they will check some parameter. If that parameter will match, then only this router will become neighbor. Okay, so what will be the state? There are some state in OSPF, right? So each and every router will follow those steps to form neighborship. Let me talk about those states. Okay, so now topic is very simple. OSPF neighborship states. You know, we have 7 types of states in OSPF neighborship. Number 1 is, can anyone know about the OSPF neighborship state? First of all is done. Down means your interface is not sending hello message and your interface is not receiving any hello message. So that interface will be considered as down in OSPF. Maybe you have configured OSPF on the interface of router, but that interface is not sending hello message, or that interface is not receiving hello message. So that interface will be considered as down in OSPF. I'm not saying that port is shut down. This down is a little bit different from shutdown. This down means down in OSPF. Okay, down. Suppose the interface is down, showing down in OSPF. That means that interface is not even sending hello message and not receiving hello message. Okay, let me write here.
Like line protocol down, link down.
Okay, we can see it. Router is not, or we can say router is sending hello message but not receiving hello message. Maybe router is sending hello but not receiving hello message. Fine. So let me show you here. Suppose I will disable OSPF. I am going to disable OSPF on router 2. Say no router OSPF 1. Okay. Now here on router 1 also, first of all let me check. So IP OSPF neighbor. So there is no any neighbor, right? I am going to disable OSPF on this router as well. No router OSPF 1, and here I am going to change the loopback IP address. IP address is 2.2.2.2, 255.255.255.255, and now I am going to enable OSPF router OSPF 1 network 0.0.0 255.255.255.255, and area is, let's say, 0. Here also I am going to configure router OSPF 1 and network is 0.0.0 255.255.255.255 and area is 0. So IP OSPF neighbor. Now here you can see state is two-way. So earlier state was down, then it will come in init, then it will come in two-way, and if you will check now you can see state is still in two-way, but within few seconds it will move in X start, exchange, loading, full. When a state will go in full, then only router will send routing information, router will send their database. Until then router is not going to send. And now you can see neighbor is still till two-way state. Now maybe neighborship will stuck in two-way state, so you have to troubleshoot it, that why my neighborship is stuck in two-way. So we will understand these things, how neighborship can stuck in two-way. Okay, now if you will check, now here you can see neighborship state is full. So I am talking about these 7 types of state. So first state is down. Down state means router is not receiving any hello message, but router is sending hello message. What will happen if I will say I will set one, so what we say, one ACL on F0/0, so that router should not receive hello message. Then you will see this neighborship state with this neighbor will be in down. Okay, and what we can do, let me, okay, for now I am not doing this. We will do these things while configuring OSPF. Okay, so first state is down, second state is init. Init means initializing. Once router will receive hello message on their interface, state will be moved from down to init, right? Okay, after that third state is, first of all let me write all states here, then we will discuss one by one. Two-way. After that fourth one is X start. What happened?
I think mm, after down, the second is attempt, then init.
Okay, we can add attempt as well between, not between down and init, between init and two-way. Okay, between init and two-way we can add attempt. Right, then there will be 8 state. Okay, we will discuss of that later. Just wait, sir.
No. Once when
Actually, that is for serial interface. Okay, actually there are lots of concept. In our case here, in this topology, there will be no attempt state. Okay, there is no any attempt state. Okay, there is only 7 state in this in this diagram. First one is down, then init, then two-way, then X start, exchange, loading, full. Okay,
when I log in the NPT,
right, that is exceptional. Yes, in NPT 1100 there is attempt state.
there is, going to attempt
Yes. Okay, we will discuss about that one as well later. Now fourth one is
loading
X start.
and start. Okay,
X start. Fifth one is exchange. And sixth one is loading. And seventh one is full. Full neighborship means OSPF have exchanged their database with their neighbor. Okay, full state means OSPF have exchanged their database with their neighbor, then only neighborship state will reach in full state. Okay, fine. Now there are two types of neighborship in OSPF: neighbor without adjacency and neighbor with adjacency. So if router will form neighbor without adjacency, that will be till two-way state. Neighborship till two-way state means neighborship without adjacency. This one is neighborship without adjacency. Neighbor without adjacency. Okay, and full means neighborship with adjacency. Oh my god. Neighbor without adjacency and full means neighbor with adjacency. It means neighbor with adjacency. Fine. Neighbor with adjacency means we have already shared database with each other. Okay, now we need to understand each states one by one. So as you know, down means suppose there are two router.
sending the packet but not receive the.
Yes, suppose there are two router. This router is sending hello message, but this router is not receiving any hello message on this particular interface. So this interface will consider as a down. Okay, on router will receive hello message on this interface, state will be moved in init from down,
Down.
right?
Now init.
Yes, and there will be one more state, that is attempt after init, but attempt state will be observed in static neighborship only, not in dynamic neighborship. Okay, there is no attempt state in dynamic neighborship. Fine. So you know, second step is in second step or in second states we can say there are two types of state. One is init and second one is attempt. Init is for dynamic neighborship and attempt is for static neighborship. Or we can say attempt state can be observed on non-broadcast multi-access network. So you know why I am not explaining attempt, because now you are not able to understand what do you mean by non-broadcast multi-access network. Okay, so attempt state will be in two cases only. First case in the case of static neighborship, and second one is in when network type is non-broadcast multi-access. Okay, so later we will discuss network type in OSPF as well. Then you will came to know, then I will show you as well attempt state. Okay, so now just focus on init state. Init state means router have received hello message on that particular interface. Okay, then next step is two-way. Next step is, let me take my pen over here, because now I am going to discuss very important things. Okay, so suppose I have two router 1 and router 2, both are directly connected. Okay, so if this router is sending hello message and receiving hello message, that means now state is in init. Okay, and as you know, in hello message there is one field called neighbor router ID, right? As I mentioned here, in hello message you can see where is content of hello message. Here there is information of neighbor router ID, right? So in first hello message, how router will put neighbor router ID, because R1 don't know anything about R2, what is the router ID of R2, right? But when router 1 will receive hello message of R2, and then in next hello message router can put their neighbor router ID as well, right? Are you getting my point or not? No problem. If I need to explain multiple time, I can explain, no problem at all. Just let me know you are getting or not.
Can you please explain this to you?
Okay, what I am saying, see here. Okay, I have already captured the data between router 1 and router 2. So where is my capturing? Let me show you my capturing first. Here it is. Okay, now I am going to remove OSPF from both router, from router 1 also and from router 2 also. Say no router OSPF process ID 1, and on router 2 also let me say no router OSPF 1, and now I am going to configure OSPF again. Okay, so now you can see router is not sending any hello message, right? Here is capturing, fine. These are another type of message. This is not message of OSPF. Now let me configure OSPF over here. Router OSPF 1 and network, suppose 0.0.0, 255.255.255.255, and area is 0. So once I will run this command, router will start sending hello message. Yes or no?
Yes.
You can see router is sending hello message.
Yes.
Which router? Router number 1 only. But router will not receive any hello message because I have not configured OSPF on router 2. So here you are not able to see any neighbor router ID in the hello message. Yes or no?
Yes.
Fine. Is there any information about neighbor router ID? No. Because till now router 1 don't know about their neighbor, and there is no any active neighbor. But once neighborship will form with router 1, router have to share the information of their neighbor with another neighbor. Like router need to tell who is active neighbor. Who is my active neighbor? Now in the hello message router is saying I don't have any active neighbor. Fine, sir.
Right.
Now I am going to configure OSPF on router number 2. Until now, if you will run do so IP OSPF neighbor, you can see there is no any neighborship. But if I will configure a static neighborship here, neighbor 12.1.1.2, it is asking for incomplete network type. Still it's not showing, so let me remove the command. Router OSPF1 neighbor is say 12.1.1.1, not 1, 12.1.1.2. After that we need to define priority, or we can define cost as well. So cost for this neighbor is suppose 10, and after that suppose priority is 1. Before that I need to define network type. So how we can define network type in OSPF? For that we need to go on interface, and on interface you will run IP OSPF network type command. Okay, so let me remove this command, this two command. Now let me configure OSPF on router number 2. Where is router 2? Here it is. Say router OSPF 1 and network 0.0.0.0.255.255.255.255 and area 0. Once I will hit enter, this router will also send hello message, yes or no?
Yes.
Let me hit enter over here. Now you can see this is where is first hello message of. Let me stop the capturing. Okay. Now where is first hello message of router 2? This one is 12.1, 12.1, 12.1, 12.2. This is the first hello message of router 2, right? So after receiving this hello message, you can see next hello message is this one, who is sending router 1. So in this hello message, router can put information of their neighbor, yes or no?
Yes.
So let me open this hello message in detail. Are you able to see neighbor router ID here?
Yes. Yes. 12.1.1.1 and that.
Exactly. So my active neighbor is now 2.2.2, means I have already received hello message from a router whose router ID is 2.2.2. Yes or no?
Yes.
So what I am trying to say, that whenever router will receive hello message from their neighbor, and in that hello message, if router will found their own router ID in the field of active neighbor field, in the field of active neighbor field, if router will found their own router ID. So in my case, router ID of this router is 1.1.1.1, router ID of this router is 2.2.2.2, right? So this router is sending hello message, and this router is also receiving hello message. So now my state is in init state, right? But when next hello message, router will send active neighbor router ID as well, that my router ID is 1.1.1 and my neighbor router ID is 2.2.2.2. So once router will find their own router ID in the active neighbor field, state will be moved from init to two-way, right? So that means if neighborship will stuck in any state, that means router is not able to find their own router ID in the field of active neighbor, yes or no?
Yes. There is a problem in hello packet.
Yes, means router is not including their neighbor router ID in the hello packet, and until router will not find their own router ID in hello packet, state will not move from init to two-way. Okay,
Got it, sir.
got it, very good. Now next state is now neighborship is in two-way. See, in two-way router will check their own router ID in hello message, right? In this state, bidirectional connectivity is actually checked, right? If router will receive their own router ID, that means there is bidirectional connectivity. This is like unicast communication between router 1 and router 2, right?
Can you just going one step back? If you just go to the hello packet,
Okay. So see, first of all, once you will enable OSPF on this interface, this router will start sending hello message from this interface, and state of this interface will be down, right? When router will receive any hello message on this particular interface, state will be moved in init. Okay. And once router will find their own router ID in hello message, state will be moved in two-way. Yes.
okay, so where does the state move in two-way, in router 1 or router 2? Because when router 1 is receiving the first hello packet from router 2,
Okay.
right, router 2 will be sending the neighbor router as 1.1.1.1.
Okay. Now, so see here, sir. Here, this is first hello message of router 2. So till now, neighborship of router 2 is init, because router 2 is receiving only hello message.
Correct, but the hello message it receives from router 1.
But when but yes, but when router will receive this hello message, second hello message, in this hello message there will be information of neighbor router ID.
So if you open the first packet from dot 2,
From dot 2, so this one is first packet from dot 2. In first packet, router is not sending neighbor router ID. See.
okay,
Okay.
but why is, I mean, okay, so it's that's how it is designed, that in the first update it will not share the neighbor ID, because dot 2 now knows the neighbor ID but is not sharing.
Yes, but it's not sharing. Once router will receive their own router ID, router 2. Maybe in second hello message, router is going to send their neighbor router ID in this hello message. So until router will not send neighbor router ID in hello packet, state will not move from init to two-way. This is what.
Open the first packet from 12.1.
Okay, first packet from 12.1 is, I think.
Any packet until it receives the response. So
Okay, so let me open this one.
yeah, I just want to see, is it sharing its own router ID in this packet?
Yes, definitely it will send their own router ID, but it is not sending their neighbor router ID.
Because it does not know its neighbor. But when 12 is the second router is receiving this first packet,
Yes.
it is able to see the